Hi Rock Buds, Papa here. Hope you guys are doing great. Have another rock story for you today. This is called Rock Story Banded Iron. We're going to find out how this beautiful and unique kind of rock got formed and what it had to do with Earth's early atmospheres. So if you like this video, please subscribe. And thank you so much to everyone who has subscribed. I do appreciate it immensely. So here we go, Rock Story Banded Iron. Let's take a look at this colorful rock with an interesting story. Did you notice the lines or stripes? Let's look closer at those. Banded iron is made of red layers, which are very iron rich, interspersed with tan layers that are very chert rich. And as you know, chert is microcrystalline quartz. Banded iron formation rocks are found all over the world, but they all date before about 2 billion years ago. To figure out how this iron-rich rock formed, we got to go way back in time, so let's do. About 3 billion years ago and before, the Earth's atmosphere was very different from what it is today. The major component of the Earth's atmosphere back then was carbon dioxide, CO2. All this carbon dioxide came from the many volcanoes that were constantly erupting on the surface of the Earth. There were no plants or animals existing on the Earth at that time. Basalt lava is full of iron, and so the basalt lava that erupted from these volcanoes weathered down to the iron, and the iron was washed into the oceans, filling them up with a tremendous amount of dissolved iron in the water. After all the basalt was washed away, exposing the granite roots of these volcanoes, then quartz began to weather out, flow down the sides of the land, and get dissolved into the sea. This happened in cycles over and over. Iron-rich water, quartz-rich water. Then about 3 billion years ago, something happened. Let's take a look at that. Blue-green algae appeared and began to flourish in the carbon dioxide-rich water of the oceans. Like all plants, the blue-green algae took in carbon dioxide, using it in their metabolic processes and producing as a waste product good old oxygen. The dissolved oxygen in the water combined with all the dissolved iron in the water, precipitating iron-rich compounds like hematite, magnetite, and limonite, which fell to the bottom of the oceans in rich red layers. The iron combining with the oxygen created iron oxide in the form of hematite, magnetite, and limonite, all forms of iron. After the iron in the water was cleaned up and precipitated, and the granitic roots of these mountains were exposed, then microscopic dust particles of quartz would drift out into the deep ocean, forming layers of chert on top of the iron layer. And these cycles of iron-rich layers and chert-rich layers happened over and over and over, building up these banded iron formations. And so, rock buds, all this oxygen that was accumulating in the water began to diffuse out into the atmosphere, and all this carbon dioxide in the atmosphere began to diffuse down into the oceans for the algae to take it in. And that created a very pleasant place for creatures like plants and animals to thrive. Sometime after about 2 billion years ago, no more banded iron formations began to accumulate. Why? Because all of that excess dissolved iron in the oceans had been removed. Banded iron formations provide most of the low-grade iron that's mined in the world today. And see those red dots up there in Minnesota? That's the Mesabi mountain range where they have tremendous deposits of banded iron and they mine them. Here's another place, it's in Brazil, where they do mega mining of banded iron formation. And this is what it looks like. There's also a bunch of banded iron formation in the Hammersley Range in northwestern Australia, and they mine that. In this enhanced photograph, you can see the red layers of banded iron. Okay, most excellent rock buds. That's the story on banded iron formation. Thank you so much for watching. And if this video is helpful, please subscribe. And this is your Rock Papa saying, happy rock hunting. Papa out.